Hi everyone. Today I want to talk about graphing tangent and cotangent functions. Whoo boy. Here is the tangent function. Wow, we got right into that, didn't we? So the tangent function has kind of like a cubic shape almost, right? Now it's periodic, meaning it goes the same way or has the same pattern every single period or every single part. Now it's certainly different than secant and cosecant, and definitely different than cosine and sine, because it goes from the bottom all the way to the top. It crosses over, where we have things like our sine and cosine function that stayed within that roadmap, and where we had cosecant and secant, which stayed above and below the roadmap. Here, tangent and cotangent, you'll see in a second, kind of defies the laws of gravity a little bit. It goes from the bottom all the way to the top. So the one major difference that you're going to see is that both cotangent and tangent functions have a range of all real numbers, negative infinity to positive infinity, and that will never change. So why is it that way? Well, if we talk about tangent specifically, and we talk about our ABCDs, tangent has a lot of asymptotes, just like cotangent. And the asymptotes for tangent, if we think about the unit circle, there are two places on the unit circle where tangent is going to be undefined. And that's going to be at pi over 2, which is right here, and it's going to be at 3 pi over 2. So the 90 degree and 270 degree mark is where there is no value for tangent, which means that it's going to repeat every period of pi. So that's going to be one of the major differences in terms of tan and cotan. The period is not 2 pi for these particular functions. The period is pi. Now, if we take a look at that, we're going to see that in this one period of time from 0 to pi, the function completely repeats itself. So if we were to go to 2 pi, there is already a duplicate. So the period for tangent and cotangent is going to be pi. Now, that makes graphing actually a lot easier. If we can graph one period or one section, then we know the repeat or the wave of this is going to be the same. So let's take a look at cotangent. Asymptotes are certainly a thing here too. Cotangent should look really similar. It's exactly the opposite. So instead of starting low and curving to go high, which tangent does, cotangent starts high and goes low. Now again, there are two specific points on the unit circle where cotangent is undefined. Now if tangent is undefined at pi over 2 and 3 pi over 2, cotangent, meaning x over y, is going to be undefined at 0 degrees, pi, and then we can go back to 2 pi. So the y over x for tangent and x over y for cotangent are really very helpful here. So let's do some graphing. So let's go ahead and start graphing our function. We know that there is no value for b next to theta, so our phase shift is just going to be left 5 pi over 3. All right, well, this graph is set up nicely. So here is negative 5 pi over 3. That is going to be a hash mark, but it's going to end up turning into a dot in a second. Now let's add the period. Remember about tangent and cotangent. The period is just pi. So if I were to add pi to 5 pi over 3, well, the negative 5 pi over 3, I'm going to get negative 2 pi over 3. That is going to be the end of the period, and that is going to be the remaining piece that I need here. Now, let's plot some points, and then we can use the asymptote, just so we can get an idea. So remember that in tangent, tan at 0 degrees, okay, there is actually a dot at 0 degrees. But we made a phase shift left 5 over 3. So because tangent does go through the origin, that means there's actually a dot here at negative 5 pi over 3, our first value, which means that there must be a dot also at the end of the period. Now, remember that it's going to end up going kind of like a cubic, where I'm going to go up and down from that origin point, so to speak. So let's talk about the asymptotes, because we can do the midline and vertical shift in a second, because we know there isn't one. So let's go ahead for the asymptotes. Well, if I know that there is a dot at 0 and my pi value is the period, we know that there are two key points where tangent is undefined, which is where the asymptote goes. And that's at pi over 2 and 3 pi over 2. Well, pi over 2 is about here-ish, right? So if I were to shift negative 5 pi over 3, all I need to do is add pi over 2 to that negative 5 pi over 3 and find my asymptote line. So let's do that. If I have a negative 5 pi over 3, I want to add pi over 2 to that, which is where the asymptote would have lied. So then we have this. let's get a common denominator. So this is going to be a little messy, right? So we're going to multiply this by 3 and by 3, multiply this by 2 and by 2. So negative 10 pi over 6 plus 3 pi over 6. And that's going to give me negative 7 pi over 6. Where our asymptote line is going to be. Now, if this was negative 8 pi over 6, we would be here. So it's a little bit one less than that, right? So it's going to be about here, which is right smack dab in the middle, which is where it's supposed to be. So that third point is going to be our asymptote line, or that middle line is going to be our asymptote. Okay, now we can continue that process, right? So if it was a negative 7 pi over 6, I can add another value of that to this, which I can add pi to it, or I can just go from here. So if it's the middle of these 2 points, this looks like what? 1, 2, 3. So 1, 2, 3. So another dot would be at pi over 3, right? Which means that at about here would be my next asymptote. Okay. Now we have everything that we need because there was no midline and there was no vertical shift. Or so there was no midline and there was no amplitude change. Now that would be important if I wanted to make our points go up or down, but since there isn't any, we are actually still going to be on the x-axis. Now the graph of this is going to be really, really simple. There wasn't any reflections, so we're going to be going. This is going to be hard, like that maybe. Oh, that's ugly. And then like this. And then that's terrible. It should be more like that. I'm not good at that. I'm looking over here because I want to make sure I get it right, but it's so ugly. I'm not very good at drawing cubics apparently, so that's terrible. This is our graph of tan theta plus 5 pi over 3. Just tremendously, hideously ugly in every way. Let's try something else. Second one we're going to do, 3 tan times the quantity of 2 theta plus pi over 2. So these are not the 5 points. This is what I'm looking for, which means the middle of this value is going to be 0. 0 is going to be the asymptote. And then I'm going to be adding pi over 2 for every other asymptote. So it's going to be here and through here and so on and so forth. Now, again, it's going to look barely recognizable in terms of a cubic. Oh, look at these ones. These are way better. Okay, that one's not good. And this is our tan function here. Okay, so because we had a horizontal shrink and because we had a vertical stretch in the same function, this function is going to be highly periodic and it's going to repeat frequently. Let's move to cotangent. Let's do a cotangent function. 2 cotangent times the quantity of theta over 2 minus pi over 3. First, just like always, we're going to plot our phase shift because there clearly is one. Now, I've got a right pi over 3, but I have to do c divided by b because there is a coefficient here. Pi over 3 divided by 1/2, which is negative pi over 3 times 2, or negative 2 pi over 3, which is right 2 pi over 3. So if this was 3 pi over 3, then 2 pi over 3 is going to be about right here. And I'm going to make a dot. Now, remember that the period normally for a cotangent is pi. So I need to figure out what the period is, and then I can add it to this. So if it's pi, I'm going to have to divide it by 1/2, or it's multiplied by 2, which means the period for this function is, I'm going to add 2 pi, which is the full period for this function, to our point right here, which was 2 pi over 3. So when I add those two things together, this is 6 pi over 3. I'm going to get 8 pi over 3, which is going to be the end of the period for this function. Well, if it was 9 pi over 3, it would be 3 pi right here. So 8 pi over 3 is probably going to be right about here, a third of the way between 2 pi and 3 pi. Now, here is our period for this function. Remember tangent, when we had our 2 points, they were actually points on that graph, meaning I could find asymptotes by finding the middles of the next 2 values. Well, cotangent is exactly the opposite of that. The 2 points that we find, the beginning of the period and the end, are the asymptote points, are the asymptote lines. So when we find our 2 points, unless there is a midline change, which there was not, we're going to make our asymptotes. So we have a line going up and down, and we have another asymptote right there. So all we really need to do is find the middle of this to find the point where we will have our cotangent function live. So if the difference of this thing was 2 pi, I can just subtract 1 pi from each of these values. Now remember, this was 8 pi over 3, and I think this was 2 pi over 3. Well, there's a 6 pi over 3 difference. I can just add 3 pi over 3. So 5 pi over 3 is going to be where a point really is. So if 2 pi is 6 pi over 3, then I have a value right about here, which looks about midway through. Now, the thing to remember about cotangent, it starts high, goes low. So from our point, we are going to make our, and again, I'm so bad at that. Why am I so bad at that? I'm usually really coordinated. That's still really ugly. Hopefully you get the point. Oh, this is so bad. Okay, yeah. All right. Now I can go, I can subtract 3 pi over 3 from here. This is so bad. So negative pi over 3. So there's a dot maybe here-ish, right? I should just do that, right? I should, it's not exactly that, but it's kind of like that. Okay, so I don't know, this is like this mutant kind of thing going on here, and this is better. Okay, cotangent goes high, or starts high and goes low. Starts high and goes low. Let's move away from this one and try one more. Okay, last one for today. 3 cotangent times the quantity of theta over 2 minus 3 pi over 4. So first step is, let's make our first point, which is going to be our phase shift. So I have a negative 3 pi over 4. And I'm going to divide that by our b value, which is 1/2, or multiply it by 2. So we have a negative 3 pi over 4 times 2, which is negative 6 pi over 4, which turns out to be negative 3 pi over 2. So negative 3 pi over 2 is right 3 pi over 2. So this is pi over 2, 2 pi over 2, 3 pi over 2. So we have a dot right here. OK, now let's add the period to that. So we're going to do 3 pi over 2. Plus pi, but again, we have this pi divided by 1/2, which is 2 pi. So I'm going to be adding 2 pi to this value because our period for this particular function is 2 pi. Yes, the parent is pi, but because I have some horizontal stuff going on over here, I'm going to be making it 2 pi, which is just going to be 6 pi over 4 pi. 4 pi over 2, which is 7 pi over 2, which is the last value here. So if this was 6 pi over 2, 7 pi over 2 is going to be right about here. OK, now remember cotangent functions. Oh, there's a marker I'm stepping on. I thought that was the dog's tail. Jeez. He didn't yelp, so I guess that's fine. Where is he? Whatever. So remember cotangent functions. The first point and the last point are my asymptotes. Now again, there was no midline change here. So there wasn't any shift up or down. And we would have had to do that before we made our asymptotes, right? And it says that there. So anyway, now that we have our first point and our last point, remember, we don't need the 5 points. And we have a middle point here. So 7 pi over 2, 3 pi over 2. So the middle would be a difference of 4. So 2 pi. So this is 5 pi over 2, which is right here. So this is going to be where my start rate goes. And my cotangent function, I think the problem is I'm trying to curl it beforehand. I'm just so bad at this. I'm really just not good at this. I think I'm trying to make it too fancy. Let's try another one. So right here, yeah? OK. And then the asymptote will go right there. Is that right? The only reason I'm doing this is because I have to redeem myself. These lines are terrible. That's right, yeah? That looks, yeah, OK. I don't know what it is about the first one, guys. It's terrible. The second one's so much better. Here's my cotangent function. Let's finish up. Titan, you come over here and try this. It's not easy, right? So let's say, I know. I know that I know I'm live. I have to. Things to remember about this video. Number 1, I'm really bad at making tangent and cotangent lines. Number 1B, remember the new rules, right? They're actually less, and they're better. Number 2, because of the frequency of asymptotes, tangent and cotangent are probably going to be the easier functions to graph in relationship to the other 4. And then number 3, just like the other 2 videos about graphing, knowing transformations and understanding what happens on the graph makes this a lot easier. See you next time.